Alright, so today we're going to look at the limit definition of a derivative, what it is. So take a second and try to answer question number 1 and number 2 for me. On October 14th, 2012, Australian skydiver Felix Baumgartner broke a world record for a high-altitude dive when he ascended 127,850 feet in the helium balloon and then went into a free fall lasting more than 4 minutes. Baumgartner's elevation above sea level, t seconds after stepping off the balloon, can be approximated by this function for time between 0 and 50. Let's see if we can estimate his velocity exactly 40 seconds after leaving the balloon. So, what is that? His average velocity between t equals 39 and t equals 40. Okay, so what's that going to be? So we'll plug in 40 inside the function, and we'll then plug in 39 inside the function, and then we'll divide by the difference. So, what's that? So you get, 102,250, 103,514, and then divided by 1. So, and that's feet per second. So that's what? Negative 1264 feet per second. Okay. What is his average velocity between t equals 40 and 41? So, we're going higher than 40, and then we went lower than 40 for A. So let's see what happens here. So what happens here is I'll say 41 minus f of 40 divided by 41 minus 40. So what am I going to get here? So still 1 unit, right? So feet per second. So this is what? Negative 1296 feet per second. Okay, so what can happen to get a better estimate? I can make an even smaller interval. So something closer and closer to it. Okay. Alrighty. So let's think about something for a second. So this is taking 40. So if my time was 39, so I could look at something like this. So f of 40 minus a 1, so take away a unit, and then subtract it from the function evaluated at 40. And then we divide by a negative 1. So right here I'm subtracting a 1, and then I could be divided by this negative 1 because it's a difference of a negative 1. And then what about this one? What if this one looks like 40 plus a 1 minus f of 40. And for this one, I'll be dividing by a positive 1. So these two things would match here. Okay, that's going to make sense in just a second when we do number 3. Okay, so number 3, we're going to find the average velocity between t equals 40 and t equals 40 plus h. So some h value, okay, so some h value that I'm going to be plugging into my function. It could be something like a decimal. It just could be some really, really small. So let's take a second now and try to answer number 3. All right, so if I take f of 40 plus h, that's going to be 1, 2, 127,850 minus 16 times 40 plus h, all of that squared. So it's 127,850 minus 16 times what? 40 plus h times 40 plus h. So it's 127,850 minus 16 times what? 1600 plus 80h plus h squared. If I distribute that, that's going to be what? Negative 16h squared minus a 1280h and plus a 102250. So now if we take that and subtract f of 40, so what is f of 40? So f of 40 is 102250. Well, that's interesting. That's the same number, right? So this is your y2 minus your y1, right? So the function evaluated at your y2 and the function evaluated at your y1. So then we're going to take f of 40 plus h minus f of 40. And when I do that, what is going to happen to the 102250 value? So we're going to add it, and then we're taking away it. So what's going to happen? I'm just going to be left with that value. Okay. So now, if I just divide by h, so what in the world? Why am I just now dividing by h? What happens? That's going to be the change. So your x2 minus your x1. So your x2 is 40 plus h. And your x1 is just a 40. So what happens to your 40s? They go away. So that's going to be what? A negative 16h squared minus 1280h just divided by an h. So what value of h would represent his velocity at exactly t equals 40? Can we use that value? So what would happen at exactly 40? I would get a 0 over 0. So I wouldn't be able to use that value. So what happens now? Can I determine his velocity using calculus? So can I take the limit as that h approaches 0? Could I take the limit of that change in my velocity and get something? So what's that? Negative 16h squared. What happens with your h's? Oops, I forgot my limit part. Sorry. So can I factor out an h? All right, what happens to my h's? They go away. So I'm going to be left with a negative 16 times 0 minus 1280. So that's going to be a negative 1280 feet per second. So that is the derivative of the function evaluated at 40. Okay, and that will be his velocity at 40. So the speed of sound is 1,125 feet per second. Did Bumgarner go supersonic at 40 seconds? Yes, pretty cool. He did. Yes, he did. Okay. So let's talk about the limit definition of a derivative. So we have two definitions that we can use. So we can have some point here. And let's call this A. And then it'll be the function evaluated at A. And let's call this point A plus H. And then it'll be the function evaluated at A plus H. So this distance here that I've created is going to be H units. I don't know exactly what it is, but it's H units. All right, so the definition of a derivative is the change. So it'll be the function evaluated at adding the H value to some H value, some distance, and subtracting your f of A. And this is all over A plus H minus an A. So if you take the limit as H approaches 0 of that, you will just be left with f of A plus H minus f of A all over an H. And what this gives you is the derivative, so f prime, evaluated at A. It gives you the slope of a tangent at A. All right, so we have another definition, very, very similar. We'll call it X's and A's. So here is A, and then the function evaluated at A. And this is going to be called X, and then the function evaluated at X. So this limit definition is a little bit different. It's where it gets closer. This distance just gets closer and closer to A. So it's not getting closer and closer to 0. Like we want to make this really, really small. So we're not, instead of making it close, the H value closer and closer to 0, we want this function to get closer and closer to A. So we call this the limit as X approaches some A value. So it's f of X minus f of A all over X minus an A. And that's the definition. The derivative of the function evaluated at A. So the equation of a tangent line at that A is your point slope formula. So the equation of that tangent line now at A, remember y minus y1, it's going to be equal to your slope times x minus x1. Remember we talked about the slope is the derivative, and that change, we haven't formally defined it. And let's put it in terms of what we know. So this will be y minus the function evaluated at A, and then x minus that A. All right, so that is the definition, the limit definition of a derivative. Let's finish this sheet and upload your notes into Canvas, please.